Hello, in this lesson, we're going to talk about solving simple cosine equation. In the last lesson, we talked about solving simple sine equation. Of course, these are if statements, right? And we talk about that it's a DRA, right? From ARD to DRA. So now the if statement turn the question from A to D, become D to A. And once again, it's in the context of function, right? And we're going to talk about how to solve cosine equations. And right here, I want to show you the making of these examples and how we solve these equations. Okay. Well, instead of sine rule, now we're dealing with the cosine rule. Okay, so I'm going to make some changes, right? So I'm going to make some, say, a square root of 2. So we start with a special terminal. Okay, special terminal. And then we'll be looking at what if it's a cosine, 1/3, right? What if it's a cosine, say, in this case, I want to make it, let's make it 5/13, right? So we just make examples. But along the way, we cover these, positive ratio, negative ratio, they're all covered. And I also like to insert a negative special terminal, right? So I'm going to make that to be cosine of negative. So we're going to make this a negative half. Right, that's a cosine. So we're looking at these examples. Okay, so these are the examples we're gonna talk about. And let's look at the first one. Okay, once again, ARD. Okay, ARD. So example number 1, right? We're solving the equation, right? Solve for A. Right, and the equation in our consideration is a cosine equals to √2/2. We know this is special terminal, right? This is special term. This will end up with a special terminal. And then we'll think out loud. When we think out loud, right? When we think out loud, what do we think from? Well, we first need to understand, right? The meaning. The meaning in this case, of course, is going to be cosine. Right, and the angle is the input, and we're looking for angle. So we're from the definition, we're looking for input. So we know the output is √2/2, and we're looking for input. And because this is special angle, right? This is special angle. So all the statement you can see, I'm doing this, based on the similar examples we did for sine, right? I want you to see this. There are a lot of similarities because the idea and the methods are the same. It's just the rule of the functions are different. Okay, so this is why I want to show you this way, right? And first of all, of course, the solution. The domain for cosine is all real numbers. How to, right? And from D to A, from D to A, right? We know the definition. The definition gave us what? √2/2, right? And once again, we still have, the three methods, right? But here, because the special properties of cosine, right? And we're solving a cosine equals to, we know the output. So the equation is different. So when we look at that unit circle, instead of looking at the blue number, right? Instead of looking at the blue number, we're looking at the, I'm going to put this away, right? So you guys are not distracted. So when we solve this equation, we know that the cosine ratio is, by definition, right? By definition, is the red number, right? It's the x over r. It's x over r. Okay, so the x over r on the unit circle, so this is x and this is r, right? R is on unit circle, right? It's on unit circle. But anyway, so we would be looking at these red numbers, and we know we also know the cosine curves, right? We also know the cosine curve, and we'll get to the method that we use a cosine curve. So we have, we're going to be looking for which ratio gave us √2/2, and it's a positive number. So we know we're going to find those numbers where? We're going to find those numbers. There's one here, and there's another one over here. First quadrant and the fourth quadrant. First quadrant and the fourth quadrant. So we found the terminal, right? DRA. So these two terminals have the same reference angle. These two terminals have the same reference angle. Okay, so these are the two terminals where the solution is going to terminate, or the other one. You see, it's pretty much the same idea when you do sine. But because it's a different rule, right? The rule of the function is different, right? Instead of being y over r, now it's x over r. So as a result, we're looking at these red numbers, right? Look at these red numbers. Well, then once we have identified these two terminals, right? And we're sitting, and it will be the same drill. So the solution, right? The solution would be what? Would be the solution in this case. Okay, I'm going to bring back that form we already did, right? So we recognize the terminal. And so here is one of the terminal is pi over 4, right? Pi over 4. And then plus what? Plus 2k pi, right? And the other one is 7 pi over 4, but we can also write it as negative pi over 4. So this way of writing is much easier to, to understand, right? Because to get to this terminal, the simplest way to measure it is counterclockwise. You ended up at pi over 4. And to end it up at the other terminal, the simplest way to get it is to measure clockwise, right? Could you show the second expression by 7 pi over 4 counterclockwise? Of course you can, right? There are many ways to express the same solutions. And feel free to explore them. So this is the first method, right? We have a special terminal and, positive, right? Negative. And so sometimes this solution can be written this way. A equals to plus or minus pi over 4 plus 2k pi. Okay, where k is integer. So this is the other way, I would say a more compact way to write the solution to our question here. Okay, so in terms of how to show work, let me move that. Okay, those are the residuals from the previous time. Sorry. To just clean up a little bit, forgive me. Okay, so in this case, how do you show your work? You just have to show, you can remove that. So let me write it down, show work. Right, how do you show work? If you to show your work, it's pretty much, you can just show one of these. Okay, show one of these. If I were you, I would show my work this way. Okay, those are the residuals from last time, right? Those are just ignore that. So I'm going to remove that, and I'm going to remove that. Simple and clean, okay? Simple and clean. So this is how you can show your work. So let's look at the second method. Let's look at the second method, right? The second method, once again, is the same question, right? It's the same question, but we're going to use definition. We're going to use definition. Okay, what does definition say? Right, so this time we're dealing with the cosine. We're dealing with the cosine, right? And the picture needs to be redone. This picture needs to be redone. Okay, so we're gonna get there, right? So xy is a point on the terminal sides of the angle other than the origin, and cosine equals to x over r, right? And here is √2/2. And here comes the question. Here comes you can view it, right? You can view it as √2/2 in the numerator, and the denominator is 1. And then you're back to the unit circle. We're back to the unit circle. So in that case, and x, right? Because that's x over r. X is going to be √2/2. And r is 1. So that would be the same question. That would be the same question, okay? But here, I want to show you some I want to show you something else. I want to show you something else, okay? So ignore these, okay? Because these are from the previous sine situation, right? So remove that. So if this picture, if I chose this way, because it's a special terminal, right? So we just need to make some adjustment. We just need to make some adjustment. Certainly there's nothing in the second quadrant because it's a cosine, So everything in the second quadrant, I'm going to remove them. And they're gone. Right? And we need something in the fourth quadrant. And of course, for the existing one, we need to make it just a little bit adjustment, right? So I'm gonna I'll be adjusting so this is going to be √2/2, right? That's √2/2. And the other one is also √2/2. Okay, so that's the blue. And that's gonna be √2/2. √2/2. There we go. Okay, there we go. It's kind of small, right? So let me change that to unit circle because this time we actually have chosen a unit circle. I'm doing this for another reason, okay? So I'm just going to make a little bit of adjustment. I'm going to make a little bit of adjustment. So if you don't remember every number on the unit circle, it's not the end of the world, okay? It's not the end of the world. And I'm just trying to make it nicer. Okay, there you go, right? So that's the first quadrant. And of course, there's a fourth quadrant, right? Because we're looking at the red number. So what is the red number? This piece, right? This is a red number. We have the blue, we don't need the blue. You see, we don't need the blue, right? So I'm going to draw the red number. So the red number would be, the red one would be √2/2, 0, and the red. I'm making it thicker. There you go. So the red is √2/2, which is the x. And I chose r equals 1. So this question essentially is the same as the previous one, but I will show you another one. Okay, just 1 second. And so the next one, of course, is going to be in the fourth quadrant. Okay, in the fourth quadrant. Wait. So, yep, that's right. This one, right? And the red one, oh, it's already the same of the red one. So we just need to draw that, we just need to draw this piece, right? So it makes a right triangle, makes a right triangle. But anyway, so when we are given cosine, right? So by definition, you can see that from definition, from the given, we can draw these pictures by definition, x over r, right? And you can choose x to be root 2, r to be 2. You can also choose x to be root 2 over 2, r to be 1. So we have the flexibility, right? Besides, it doesn't matter which point we choose x comma y on the terminal side of the angle other than the origin. As long as it is not the origin, any point we pick on the terminal would be fine, would be just fine. Okay, so here we go. We get the solution. We're going to express it. Right? So, and this solution, this number, of course, we know it's pi over 4, right? This number, we know it's pi over 4. This number can also be represented by arc cosine root 2 over 2, just to let you know. And the other one is a negative. So one is negative, negative pi over 4. The other one is pi over 4. So let's represent our solution. So we can just go straight, right, to our plus minus pi over 4 plus 2k pi plus 2k pi, right? And k is being any integer, same conclusion, okay? But for this second method, I want to draw you another picture, and I could just give you another perspective, okay? Just give you another perspective. So another version of method 2. Another version of method 2, okay? So instead of treating this as a unit circle, which you can always do, I'm going to treat it as, instead of radius 1, now I have radius 2. So I'm going to treat this as x over r, right? So this is x. So x is root 2. R is 2. Can I do that? Of course you can. Of course we can, right? Of course we can. It's just this picture, this picture is going to be changed. Okay, so I'm going to take this picture and draw you the x equal root 2 and r equals to 2, that picture. Okay, so, and of course we need a larger area. So what I want to show you, I actually want to remind you that, when we talk about y unit circle, we want to just reflect on that piece. Okay, reflect on that piece. So I'm going to make a little adjustment, right? So I'm going to make the, I'm going to, change the scale a little bit. So this is on unit circle. This is on unit circle. What if I don't choose unit circle? Now radius is 2, right? For radius is 2, we basically have this radius instead of 1, now the radius is 2, double the length. X is root 2, right? And root 2, okay, and the red is going to be longer. It's going to be longer. That's the only difference. And the blue as a consequence, right? The blue as a consequence is just going to be longer. You see? So so this small triangle and the large triangle, they're similar triangles, That's the only difference. That's the only difference. So let me draw those pictures for you so you can see that perspective. Okay, you can see that perspective. So the first of all, this one, so I'm going to add. So this is divided by 2, so square root of 2, right? So it's just everything divided by 2 now is no longer divided by 2. It's just they're proportionally changed. You see that they're being changed proportionally. That's what I wish you to understand. Okay, it's just a proportional. And so this is one, and let's do another one. Hold on, let me just finish this one, right? So that's the blue. Okay, I'm gonna remove this blue and remove the green, right? It just clear it, right? Because the drawing in with the existing software is better. And I'm going to draw the, the radius and the red, right? I'm going to draw the radius and red. So that's the radius, right? So this is the piece. So proportionally, instead of dividing by 2, it's just not dividing by 1. Okay, there you go. And the red is longer, so you can see the proportion. You can see the proportion. Okay, so where's my red? And that's my red, right? So divide by 1. There you go. Right? You can see that's how it doesn't change the angle. It's going to be the same angle, pi over 4. So it doesn't matter you take x as root 2 over 2, like in this case, right? And in this other case, you choose x equals to root 2, and r will be proportionally larger. And the same thing will happen to the one in the bottom. So let me just finish this one. I just finished this one. So we have a sense of completion. Okay, so you see the proportion being done. But anyway, and there we go, right? And the red stayed the same, so just one more. And there we go. Okay, so you see the proportion being done, right? But anyway, so it doesn't change the angle. The solution is still A equals to plus minus pi over 4, pi over 2, pi over 4, sorry, 2k pi. Okay, and k is being any integer. So next, method 3, you anticipate it, right? We anticipated that solution. With the third method, just a different rule, the change of rule, and of course the solution would be different, right? This was for sine, right? And let's look at the cosine curve, right? The rules are different. This is a cosine, and the output is root 2 over 2. Right, so let me put it that way. So this curve is no longer going to be sine curve because this was sine curve, right? So let's look at what is a cosine curve. Okay, so sine curve change to cosine curve. And I'm going to remove that arc. And the horizontal line is root 2 over 2, right? I'm also going to remove that arc sign. There you go. You can see that's what, if the rule has changed, the idea and the methods doesn't change. The idea and method doesn't change, right? And we got these points of intersection. And at these points of intersection, right? At these points of intersection, there are many, many of them. There are many, many, many of them. And the heights, right? Which the heights are the output for cosine, right? And those heights, right, which are red, those red heights. This is a little too thick, right? So make it thinner, right? So those heights are √2/2. √2/2 in height, that's the cosine ratio, √2/2 and √2/2, right? So that's the visual. That's the visual of our solution. That's the visual of our solution. And what would be this guy? This piece, this length. Oh, let me change it to, so this length, okay, this length is what? Pi/4. And this is the red, right? If you reflect on how we graph cosine curve, right? And this is the red. So we know the red, so we know the output. We know the output and looking for input. Okay, so at this crossing, so let's mark these points, right? And this point is pi/4, comma, √2/2. Okay, √2/2. Okay, and you can mark the rest of the point. And this point is negative pi/4 and √2/2. Okay, so each one of these points is represented by that solution in general, and they can all be marked properly. Of course, this one is 7pi/4, and square root 2/2. Okay, they have the same output. So we have identified all the inputs with the same output. Okay, so what will be the solution? Of course, the solution is going to be the same, right? So it's going to be plus minus pi/4 plus 2k pi. And k is being any integer. How do we show our work? So I'm just going to, put this on the side, right? I'll put this on the side. If you show your work, okay, if you wish to show your work, you certainly can show your work this way. You certainly can show your work this way. But you would like to do some markings on the picture. Okay, if you show your work from here and like that, you will do the marking like what I did earlier. Okay, if you put those markings on the picture, that would be amazing. That would be amazing. All right, so that's the first example, right? We use the special terminal. So let's look at a non-special terminal. Let's look at the non-special terminal, right? So non-special terminal and the cosine A equals to 1/3. Okay. So let's look at the second example. So instead of sine, this time it's a cosine. Okay, it's 1/3. So the rule has changed. The rule of the function has changed. That's all. The rule has changed. Okay. If we look at the unit circle, of course, these answers are no longer is fitting to our situation, right? So I'm going to just leave it blank here, right? We know in the end we're going to have a solution that has something to do with K, but for the moment we're going to just leave it there, right? Cosine A equals to 1/3. If we look at the unit circle, does it have a place, right? Does it have a place? Certainly, you can see it's a unit on a unit circle. You can just see it as 1/3 over 1, right? We talked about this in the earlier examples, even though this is not a special terminal. So according to definition, right, it's x over r, right? X over r means what? X equals to 1/3. And r equals to 1 by definition, right? And where is 1/3? 1/3. Well, r equals to 1/3. We can certainly draw that 1/3. This whole thing is 1, so this is going to be 1/3. Is about right? Yeah, this is 1/3, right? This is 1/3. What is r? R equals to 1, right? So r equals to 1. So we know there's going to be a blue. There's a blue, right? So the blue has to be vertical. Do we need to find what the blue is? What is the blue? We certainly can by Pythagorean theorem, right? We can find it by Pythagorean theorem. So this is the blue. There you go. We don't need the blue, right? We don't need the blue, but we just know the red is 1/3. Now, there's another terminal, right? There's another terminal. So this other terminal will be in the 4th quadrant. And that terminal will also, any angle terminate in that terminal will also have the same cosine ratio, which is 1/3. See? So we find the angle. We found the angle. So what is the angle? Do we have other terminals? No, because terminal in the 2nd quadrant, the 3rd quadrant, the cosine ratio will be negative. So we have positive. So these two terminals, the two green terminals, are all the terminal we have, right? So that's DRA. You can see from D, we found the reference angle, and then we get into the A. So next, how do we represent this angle? How do we represent this angle? Well, these two angles, they are opposite to each other. So if we can represent one, we can represent the other. And this angle can be represented by arc cosine. So arc cosine, okay, arc cosine. So if I call this angle theta, right, I'm going to introduce a theta. Theta equals to arc cosine of 1/3. And this angle will be the theta, Okay, so this is theta. So now theta is represented, how about this next one? This one is negative theta, right? Or 2 pi minus theta, right? But we want to represent our solution as simple as possible. So the solution in the end would just be what? Plus minus theta plus 2k pi, where k is integer. We got it. We got the solution. How to show work? Okay, so I'm going to show you a version of how to show work. Okay. If you are to show work, let me just do it based on this, right? You can just make it clean. Okay, keep it clean. Okay, if you are to show work, you have the picture. If you have draw a picture, whether it's a unit circle or not, it doesn't really matter. And if you use theta, you write it this way, Okay, you write this way. And if you show a picture, that would be great. That would be great. Otherwise, let me show you another version of showing work. Okay, this will be related to method 2. Method 2. So I'm going to use just cosine theta. I'll show you the version of showing work. Okay. So this is a cosine, right? And theta this time is an arc cosine, and the solution will be, you know, plus minus. So the solution is going to be plus minus, hold on. Okay. Plus minus, right, theta plus 2k pi, where theta is specified. Hold on. I'm going to put this away, right, because we don't need to explain more. I just need to change the picture. Okay, so these are the just basically notes. Okay, you can totally remove it. You can totally remove it. We're talking about showing work. Okay, so now, of course, this is for cosine situation. This picture doesn't work, right? This picture doesn't work. So I need to remove, because we need to remove this piece of picture, right? So I'm going to remove that. You know what I should do? I'm going to just remove this picture and I borrow, right? I kind of want to take a little shortcut here. Wait a minute. Hold on. Let's do it over, because that will be, let me do it over. Okay, let's do it all over again. Okay, the picture we draw, right? So we already know the solution, right? And when you show your work, it's nice to you have a picture to present it to whoever is going to read your work, and maybe giving you credits. Okay. So if I have done that, suppose I don't care about unit circle in this case. Okay, in this case, I would not worry about unit circle. And so I'm going to make my picture just proper size, right? The denominator. So what I would do, I see this as x over r, right? So x is 1, r is 3. So if x is 1, r is 3, we can find the other one, right? We can find the other one. Actually, we deleted x is 1, r is 3. So there's a red and blue, right? There's a red and blue. The red is 1, r is, let me draw it, right? So you figure out, if you like to pause this recording, right? If you like to pause and figure out how you're going to draw a proper picture. It doesn't have to be perfect, right? But because I need to use this I need to maneuver this software. So the x is 1, right? And r is 3, right? R is 3. So that's probably 3. Whatever, right? It doesn't have a precise. If we want to find the blue and we want to, draw a proper blue, if I want to draw a proper picture, if you do it on the paper, you just draw like this, as long as you mark it properly. So how do you mark it properly? So here you would say, hey, this is 1, right? Maybe this is 1, and that is 3. This is 3. Whether you mark this part, it actually doesn't matter, even though it's 2 times root 2. Okay, Pythagorean theorem, 3 squared minus 1 squared, so square root of 8. Square root of 8 is 2 times root 2. Then that's perfect. That's perfect for me. And then you can draw that piece. I'll try to keep them color coordinated. Okay. So, and that there's a blue here. right? And they share the same red. They share the same red. Oh, so this is the red. This is the model. I should not use the red. Let me use a different color. Okay. So when there are two red, right? So this, the red is X. Okay, the red is X. So this piece, and this picture is good enough. If you draw it on paper, even the line is not straight, it doesn't bother me. Well, it doesn't bother me, as long as you show that you understand the idea. Okay, since I'm doing this on the software, so I'm going to just make sure it's not too problematic. Okay, so just allow me a little bit of time, because in the circumstances, you need to have this skill to draw the picture. Okay, to draw the picture and to do it right. Okay, because I don't want to confuse you. And some of these, you will need them in the future. So this is one, right? And there's another one there. And there you go, right? So now I can delete some stuff. I can delete that. I can delete that. Now I'm going to draw the red and blue, right? I'm going to draw the red and blue. So the red, we really just need to draw the red. Drawing the blue is a bonus, but knowing how to find the blue may serve you other purposes in the future. Okay, so this is one. And here it's going to be 0. And that's going to be red. And here we go, right? And then we're going to draw the blue. Right, I'm going to draw the blue. Wait. Well, I'll just take this one, create my own. Okay. And that's going to be the blue. I want to make it thick. So one blue is drawn. And so that other blue that I drew with the other software can be removed, and one more. Okay, one more. One more. Here we go. We're almost there. Right there. Okay, so I'm going to remove the other one. Okay, the other messy one. Now here we go. Okay, so we draw such a picture, we still keep the marking there because we want to mark to show the reader that this angle is theta. This angle is theta. So on your picture, you want to mark your theta if you do show the picture. Okay, so the goal is that you want the reader to show, to show, you want to show your reader. Okay, most likely those readers are people might give you grades or not. Okay, to understand, to show her or him that you understand what you're doing. That's why you draw these pictures nicely. Okay. All right. So that's the second method. That's the second method. Third method. Third method. Okay. Third method. Of course, you anticipate what we're going to do, right? The third method. Okay, cosine. Cosine. Oh, sorry. Cosine is 1/3. You just draw a horizontal line. I'm going to remove this one and use the previous one, right? Use this cosine, right? When we do the first example, method 3. Okay, I don't want to confuse you. So let me clean up this third method to solve this equation. I'm going to remove this. These are the residuals from when we're solving sine equations, okay? So don't get confused, but I put them there for a reason. I want to show you that the methodology, the methods are the same. It's just because the rule of the functions are different. So for 1/3, instead of we're drawing horizontal line. Instead of drawing √2/2, we're drawing 1/3. Not 23, okay? And of course, I'm gonna draw the red line. Why? Because the way we're making the curve, right? We take the red number, so I draw the red. So there's a crossing, there are the crossing. There's one, that, you know, all these points who has input output, right? These points has input output. So for example, this point, the ratio, okay, I'm gonna mark the ratio is a cosine ratio, right? Oops, not the red. I need the red, okay? The ratio is 1/3, okay? And the angle, what is this angle? Let me remove that heart, okay? It's kind of in my way. So now, the arc length or the radian, right? This is a theta, this is a theta, okay? So this is a theta, and I'm going to write it down for you, okay? This is theta. Oh, I'm sorry, writing using the mouse is a little bit challenging for me. So theta is equals to arc cosine 1/3. It's the arc length, it's the radian of the angle, etc., etc. And this other one, of course, is negative theta, right? And how about this one? How about this one? How about this one? How do we get this one? Well, that would be the negative angle plus 2 pi, right? And this angle plus a minus 2 pi we get here, right? So from here, minus 2 pi we get here. And from here, we plus 2 pi we get there, and we keep going, right? So in both directions. All right, so you can see there are much similarities between the special case and non-special cases. Okay, between the special case and non-special cases, right? Basically the same idea. In this sense, we're saying that the special terminals are in service to our purpose. Okay, so the method we use to solve the equations involve special terminals is the same for non-special terminals. Okay, so in the end, we should be able to solve similar equations no matter what output is given, as long as the output is in the range. Okay, so let's look at the example number 3 and 4. Okay, so I'm going to just clean this up. You guys have it. Okay. So in example number 3 and 4, and we have our set goals of those examples, right? So these two. One is the special and the other one is non-special, but these are not, one is a special one, the other one is non-special, right? And remove these, you know, remove these. Okay, remove these and we'll come back to it. And of course, is a cosine. And this time it's -1/2. -1/2. Okay, and the next one, we're gonna do the non-special one. We're gonna do the non-special one. But these are negative ratios. What do we do with negative ratios, right? With special terminal, and of course, we're gonna look for negative half, right? Because the output is a given, right? So we know the ratio. So we're gonna working on, still DRA, right? Still, ARD, right? We're going from D to find the terminal, and then we get to the A. So A is our goal. A is our goal. D is a given. D is that we know the output, right? Definition is given to us. So on the unit circle, we have a negative half. We have a negative half. Okay, where's negative half? So let's find a negative half, right? So look for it. Oh, I see one negative half here, and I saw another one. So then we found the terminal, don't we? So we found the terminal. So these two terminals are, you see, DRA, right? DRA. We found these two terminals. How do we get to those terminals? That's the question, right? How do we get to those terminals? Well, angle. All the angles are measured from standard position for the inputs for cosine. So this angle will be measured this way. And this other angle, you can measure many ways. The simplest way is this way. And in fact, you look at these two angles are opposite to each other, right? These two angles is opposite to each other. If this is theta, and this will be negative theta. Do you guys see that? Well, how do we represent theta? It's not special. Oh, by the way, it is special. Sorry, it is special, right? It is special. So theta, what is theta? Theta is, we measure it, it's 2 pi over 3. 2 pi over 3. So here we go. The solution is 2 pi over 3. It could be positive, negative, right? And plus 2k pi. Plus 2k pi, you see? It's similar to our previous situation, isn't it? It's similar to our previous situation. In the special case, all right? Yeah, so we got it. By the way, I wish you to be reminded of that arc cosine of a negative half. Okay, so I'm going to put a little note here. Just for you, okay? Just for you. Arc cosine negative half is 2 pi over 3. 2 pi over 3. Just remember that, okay? And we're going to make a connection to it when we work on number 4. Okay, when we work on number 4. You can see in one picture, this is how you show your work. You can remove these, remove that, right? So the rest is how you show your work. You follow me? Show you follow. If you choose to use unit circle, So if you don't use unit circle, no problem. You can use definition. Okay, so let's look at the second method. Let's look at the second method. Oh, in the last one, we actually didn't talk about second method. So let's talk about, there's no need, right? I think we already covered it. So let's not do second method. Let's do third method. Third method, I'm going to remove this picture because we're doing cosine, right? And this is negative half. And I'm just going to borrow my other picture, right? I'm going to draw vertical line. I'm going to draw horizontal line, right? This picture, these are these, remove them, okay? So I don't want to mess up my work. So this time when we draw the horizontal line, instead of whatever it was, right? Previously it was whatever, okay? It was 1/3, right? So this time we're going to draw that horizontal line to be -½ There you go. And we found our solutions, don't we? And you can see all that curve that we worked so hard to get, right? So there's a solution here, there's a solution there, solution there, solution there. And what are they? Well, if you connect with what we did, right? Oops. Drawing the cosine curve. Okay, so this is the arc length, which is what we are looking for, which is 2π/3. And here is the red ratio, -½ So from output, we find inputs. And this one, so let me mark it. Okay, so this orange is 2π/3. And this red, that's -½ Okay. And this piece, right here. And of course, that's -½ too. Right, that's -½ too. And the orange, which is the arc length, is a -2π/3. Okay, so this is a -2π/3. Doesn't that all fall into places? Now, if you look at the, some weeks before, our previous lessons on how to graph a cosine curve, and all these are connected, aren't they? All these are connected. And of course, this is half, oops, change it to straight line. So this is -½ And you can recognize that angle, basically this angle plus 2π you get to here, right? And this angle, you minus 2π you get here, right? So all of these, this is -2, -½ horizontal line, we found those. And expressing our solutions, how do we express our solutions? We just say A equals to ±2π/3 plus 2kπ. Okay, and k is any integer. Okay, k is any integer. All right. 3 methods. So finally, we get to the ultimate one. Okay, the one that, it's not special. It's not special. Okay, so let's move forward. They are so similar, right? You see lots of similarities in methodology, right? So this is 13 and that's 5. Okay, and of course, we're going to do method 1, all of that stuff, right? Hold on. I'm sorry. Wait, where am I? Here we go. We're here. Okay, so I'm going to remove all of that. Remove all of that. Okay, try to keep it clean. Question at hand. Cosine equals to negative 5 over 13. We can view this as negative 5 over 13 divided by 1, right? Why not? Right? So then you fall on unit circle. We fall on unit circle. So x equals to negative 5 over 13. And the r equals to 1, right? So unit circle, but you don't see any red numbers on the unit circle here, but it is somewhere. It is somewhere. It's negative 5 over 13. Approximately, where could it be? Where would it be? Approximately, huh? That terminal, right? It's a negative 5 over 13. So it should, if you look at the numerical value, it should be less than, half, right? So let's find it. Where should it be, right? Let's find it. How do we find it? Well, you just find the numerical value. Okay, it's at your fingertips, numerical value. Okay, so I'm going to put it here. Okay, negative 5 over 13. So it's about negative 0.384. Negative 0.384 is, and this red number is negative 0.5. And this is negative 0.7. So this is a negative, it's larger than that, right? So the cosine value here is getting smaller and smaller. And so this is larger. Therefore, the terminal is most likely to be here. Okay? Okay? All right, so that's the x. What is the x? Right? The x is negative 5 over 13. It's right here. Oh, we need the red. Sorry. Give me the red, okay? Give me the red. So this red is a negative 5 over 13. And of course, we have a blue. We have a blue, right? We have a blue. If you care about what this blue is, you just use Pythagorean theorem. It should be 12 over 13. Okay, 12 over 13. So let me mark it, okay? So I'm giving you the answer. I trust you can find it, but if you have issues, just let me know, okay? So this red number, as I drew on top of, just on this unit circle, we are all familiar with. The blue, let me write down the blue. Give me the blue first, right? So let me just use the blue, 12 over 13. Okay, if I make a mistake, please tell me, okay? And I don't think so at this point. And this red number is negative 5 over 13. You see, every terminal, every angle, whether special or not special, it has a place on unit circle. You just have to find it. So this point, this point, let's practice marking this point. What is this point? What is this point? Can you mark this point? Can you mark this point? Yes, that point is, okay, the red number is 5 over 13, negative 5 over 13. The blue number is 12 over 13. Forgive my ugly writing here, but I think I made the point. This perspective, for me, is important to show you that you understand, even though you have all these special values, there are a lot of non-special values. They all have a place there. Okay, they all have a place there. But anyway, and of course, this is not the only terminal with negative is not the only terminal such that a cosine angle equals -5/13, right? So we have another one. We have another one, right? So since I got the blue, so I'm going to use the blue. We spend all these time on these questions because academically, these are the values you typically will need. You typically will find out. So we have another point. Okay, can you mark this point? Can you mark this point? This is just for the fun of it, really. Okay, can you mark this point? Let's do it. Let's do it. This point. Okay, they share the same red, so it's the same 5/13. The blue is the opposite of 12/13. Okay, so over here is -12/13. So now we have identified all the terminals. We have identified all the terminals that give us a cosine equals to -5/13. So from D, we have identified R, right? Because they share the same reference angle. They share the same reference angle. So now let's spell out A. How do we find A? A. We measure angle from the same standard position. Easiest way to measure? Easiest way to measure, what do we get? So if this is theta, and this is a negative theta, isn't it? And how do we represent theta? Well, we can use arc cosine. Because when we do arc cosine, what do? We chop off the last two quadrants, quadrant 3 and quadrant 4, right? So theta can be represented as arc cosine negative, okay, I'm going to even use the red number, -5/13. All right, so now it's time to organize our work. It's time to organize our work. It looks like I have to clean these up. I have to clean this up. I hope you guys have taken the notes, right? You can come back to see the picture, but I have to clean it up in order to write it cleanly for you. So let's go. I'm cleaning, okay? All right. So how to show my work, right? With all that drawing, and I will show you, okay, the solution. The solution is going to be, okay, we let theta equals to arc cosine of -5/13. Okay, and then the solution will be plus minus theta plus 2k pi, and k be any integer. I think you get the same answer as I did. Okay, second method, I still want to do second method here because I'm going to draw the picture. Of course, the rules are different here, cosine, and cosine A, and the output is -5/13. The rules are different. Okay, so what I'm going to use here in the second method, I'm going to draw the picture. Let's remove that. Let's do it over. Okay, let's just do it all over again. Okay, that's the third method. Okay, we're going to get to it later. Okay. Hold on. So we're going to draw this picture. Since we know the rule is a cosine, right? We know the rule is a cosine. So, and we know that the question, the if statement is a cosine A equals to negative 5/13, right? So knowing the definition, and this time we're going to draw a non-special case, right? So it's a negative 5/13. By definition, we have x over r. Okay, x over r. What does that tell us? X is negative 5, r is 13. There you go. So according to this information, we're going to draw the picture. Okay, so if you like, you can draw the picture. You can pause the lesson and draw the picture yourself. Okay, it's very important that you have this skill with you. You have this skill with you. Okay, and it's one thing that you watch it, and the other thing is doing it by yourself. Okay, very important. So I'm going to make some adjustment. Oops, 13. You know, the non-special values, typically academically, they're just 3, 4, 5, 5, 12, 13, and then the special terminals, really. If they invented more, great. I see most of these values are very commonly used. Okay, commonly used. So in the future, the question you encounter either will be special, non-special. On the next non-special one, it could be 3, 4, 5, 4, 3, 5, or 5, 12, 13 in different order, or 12, 5, 4, 12, 5, 13, right? So they just arrange these numbers in different order because these numbers are easier to manage. They're easier to manage. Okay, so now we have x equals to negative 5, r equals 13. So in the picture, negative 5 is x, and that's negative 5. That's negative 5, right? And the r is 13. R is 13. So I'm drawing the r somewhere, right? And I'm going to join the other one, right? So, and then there will be the blue. So let's draw it. Let's draw it, okay? So I'm going to draw it properly so I don't have to erase and stuff. So I'm going to have to draw it within the software. It won't take too long. Okay, so be patient with me, and you are drawing along my side. You're drawing this along my side, okay? So negative 5. And that's the red. That's the red. Done. Okay, negative 5, right? And the R. Okay, so I'm going to draw the R. Oops. Well, you don't have to learn how to use this software. And these are not red. Okay. And that's not red. Here we go. And they're too thick. I don't like it. So I'm going to change them to be less thick. Thin. Okay, those are just the R's, right? And they're the blues. Okay, I'm going to put, even though we don't need the blue, but I'm going to put the blue there because sometimes you need these skills. You need these skills. So I'm going to put the blue there. The blue, wait. What did I do? I forgot one more step. Oh, my bad. My bad. My bad. There we go, the blue. The blue is not needed at all in this case, okay? Because what we need to do is just really identifying these two angles. So this is theta, and that's negative theta. And this theta can be represented by arc cosine. Negative 5/13. That's all. Okay, so excuse me, when you draw the picture, okay, when you draw the picture, you know, it illustrates very well about your understanding, because you present the work in the proper way. It demonstrates to your reader how well you understand the topics. Okay, so now without further ado, okay, clean it up. You draw this picture, you mark this theta, okay. Here we go. Okay, you can say and show work. Okay, I'm just going to write it down how to show work. Show work. Okay, you can say let theta. You know, this theta is actually between negative pi, is between 0 to pi. And in particular, okay, it is between pi/2 and a pi. Okay, so for your understanding, I want you to understand this is between pi/2 to pi. Okay, think about the range of cosine, arc cosine. Think about the range of arc cosine. So even though this piece you don't need to show, but it's very important for you to understand it. It's very important for you to understand it. So I'm going to put it as a optional. Okay, this piece is optional for you to show, but it's very important to understand. Okay, so I'm going to put the theta belongs to. Okay, so it's very important to understand that. Pi, sorry. Okay, so when you show your work, you let the theta written this way, and you just write down your solution. Okay, you copy the question, cosine A equals to negative 5/13, and your solution is let theta equals to that, and A would be equals to plus minus theta plus 2k pi. You see, the show of work is pretty simple. It's pretty simple. But understanding the whole process, how do you show your reader you understand the process? And that's why you need to show a picture. That's why you need to show a picture, not only just to your reader, to yourself, right? So show work, what I will do, I will mark this one as theta. Not more, you don't need more, okay? And if you like to mark the other one, it's not necessary anymore, right? So if you show work like this, okay, you can exclude the brackets, right? You can remove the bracket, right? If you show your work like this, nice and clean, you will get all the credit you need. Okay, but anyway, so I leave this as a note. All right, so that's how to show work. Third method, of course, drawing picture. So I'm going to remove this picture, bring in my cosine picture, right? Bring my cosine picture. Where's my cosine curve? Here we go, right? We've been drawing a horizontal line with, negative √2/2, -½ and so on and so forth. So this time is a -5/13. So whatever that red line was, this time I'm drawing a different one, right? Instead of -½ it's -5/13. There you go. So you see the similarity in methodology and ideas, right? So these three methods, we're going back and forth. The three methods, one is about the unit circle, the other one is, definition, and third one is about the curve itself. If you have understood all these three methods, you will be invincible. You will be invincible. You can solve any question. You can solve any question coming your way. So this is theta. This is this point. Okay, this point. Okay, hold on. Let me put this. Let me do it properly. When we're doing the first method, right? So we know the solution already. Of course, we already know the solution. So how do you mark it on your work? How do you mark it on your work, right? And you have this picture to show, right? We have this picture to show. And what is the theta? What is the theta, right? In this picture, right? You know the point right here. And you know the domain and range of, cosine, arc cosine. So from here, this point, okay, I'm gonna put a star, the star point. This one has input and output, right? So how do we mark this point? This point can be marked as theta -5. I should use red. I need to be specific, right? So we can have consistency. We can have consistency. So this is a -5/13. And what is a -5/13? This is a -5/13, this height, okay? And what is the orange? The orange is this much. You see, now if you reflect on the picture, when we were plotting the cosine curve, aren't they consistent? Yes, they must be consistent, right? And so let's go one step further. Can you mark this point? Can you mark this point? Right, you can pause the recording right now and mark it and come back to watch. Right, so this point is a negative theta, right? And the red number, which is -5/13. And this point, you add a 2 pi, you get here, right? That's 2 pi. And from this point, you subtract 2 pi, you get there. So you keep adding 2 pi, you get all the solutions you want. You get all the solution you need, right? So if you choose to draw this picture, if you choose to use this picture, and that's totally fine. That's totally fine. So now from these practices, we thoroughly understand our pictures, don't we? And that is the goal. That is the goal. The red is a -5/13. Okay. So this is how to solve simple cosine equation. Okay. So let's look at another example. Let's look at another example, right? And you probably anticipate it. The next example is, suppose I have a cosine A equals to 4. Cosine A equals 4. In other words, if right? If cosine of angle equals to 4, what is the solution? Once again, we know the output, and you probably will be thinking about domain and range. And if you do, you are so right. You're so right. You're heading in the right direction. Well, cosine has domain and range similar to that of sine. No solution, of course. No solution. And here I want to show you just a little bit extra, okay, which I didn't show for sine. We're going to draw a horizontal line, right? So this time we draw a horizontal line, okay? And the line is 4. Okay, the line is 4. And let's show the picture. No touch, no touch, no solution. No touch, no solution. Okay, so here I want to put no touch, no touch, no solution. Okay, and then your question would be, is it always the case? Absolutely. It could be any curve. Okay, if you know the output of that function, if you know the curve of that function, you know the output, you draw a horizontal line, there's no touch, no solution. Okay, so that's all for this lesson. And we've covered very thoroughly in all the cases of cosine, simple cosine equations. If you have any questions, please don't hesitate to reach out to me and I'll be happy to answer your questions. Thank you for watching. Until next time.